A sample of water releases 6,180 joules of heat energy and its temperature drops from 100 degrees Celsius to 71 degrees Celsius. What is the mass of the water? So the formula that applies to this question is Q is equal to mc delta T. Q is heat, M is mass, C is specific heat capacity, and delta T is the change in temperature. So the question says, what is the mass of the water? So we are solving for M. So we need to rearrange the equation in order to solve for M. So if we divide both sides of the equation by C delta T, C and delta T would cancel on the right side, and we're left with mass. And on the left side, you have Q over C delta T. So solving for mass, that is Q, which is heat. The problem says the sample of water releases 6,180 joules. So the word releases here is actually very important because it will tell you the sign of Q. So remember that in thermochemistry, the sign convention is when heat is released, it is negative, and when heat is absorbed, it is positive. So it says here releases 6,180 joules. So Q would be negative 6,180 joules. Divided by C. C is the specific heat capacity of water. Although it is not given in the problem, we must be familiar with the specific heat capacity of water because we will encounter this in many problems regarding thermochemistry or calorimetry. So C, or specific heat capacity of water, is 4.184 joules per gram degree Celsius. And delta T is the change in temperature. So delta T is final temperature minus initial temperature. So the final temperature is 71 degrees Celsius minus initial temperature is 100 degrees Celsius. So solving for the mass, this is equal to 50.9. And if we look at the units, joules would cancel, degrees Celsius would cancel, the unit would be grams. So the answer to this question is 50.9 grams of water.